Coagulation or flocculation of colloidal solutions. Coagulation means the conversion of colloids to a precipitate by the addition of a suitable electrolyte. The electrolyte contains both positively charged ions and negatively charged ions. If the salt is positively charged, then the negative ions present in the electrolyte will cause the coagulation. The ion that causes coagulation is known as the flocculating ion. An important rule associated with the coagulation of colloidal solutions by the addition of electrolyte is Hardy-Schulze rule. The coagulation behavior of various electrolytes was studied in detail by Hardy and Schulze. They observed that the ions carrying a charge opposite to that of the salt particles are effective in causing the coagulation of the salt. Such ions are called flocculating ions. Now the rule states that greater the valency of the flocculating ion, greater is its power to cause coagulation. For example, consider arsenic sulfide salt which is negatively charged. To cause the coagulation of this negatively charged salt, let the electrolytes given be aluminum chloride, magnesium chloride and sodium chloride solution. Now since the salt is negatively charged, it is the positively charged ion present in these electrolytes which will be able to cause the coagulation. Out of the various ions present, that is aluminium 3 plus, magnesium 2 plus and sodium plus ion, aluminium 3 plus ions have the greatest charge or the valency. Hence, the best flocculating ion will be Al3 plus ions. We shall now discuss about the various methods available for the coagulation of colloidal solutions. The different methods are electrophoresis, mixing two oppositely charged salts, boiling, persistent dialysis and addition of electrolytes. Now take the first method, that is electrophoresis. If this process is carried out for a long time, the particles will touch the electrode, lose their charge and get coagulated. Now how mixing of two oppositely charged salts can lead to coagulation of colloidal solution? For that, consider two oppositely charged salts, ferric hydroxide salt and arsenic sulfide salt. Here, ferric hydroxide salt is positively charged and arsenic sulfide salt is negatively charged. When these two salts are mixed in equimolar proportions, they neutralize each other and may get coagulated. Now the third method given is boiling. When the salt is boiled, the adsorbed layer gets disturbed. It is due to the increased collisions with the molecules of the dispersion medium. This will reduce the charge on the colloidal particles, leading to coagulation. Persistent dialysis. You know that the stability of the colloidal solution is due to the presence of a small amount of electrolyte. If the electrolyte is completely removed by repeated dialysis, the salt will get coagulated. Now the last method available is addition of electrolytes. You know that in an electrolyte, both positively charged ions and negatively charged ions will be present. The ions carrying the charge opposite to that of the salt particles will be effective in causing the coagulation of the salt. Coagulation of lyophilic salts. The lyophilic salts are relatively more stable than lyophobic salts because of two reasons: charge on the colloidal particles and solvation of colloidal particles. Now, in order to cause the coagulation of lyophilic salts, these two factors responsible for their stability should be removed. This is done by adding electrolyte and by adding a suitable solvent. For example, consider a hydrophilic salt. You know that in a hydrophilic salt, the medium present will be water. So, if a solvent like alcohol or acetone is added to a hydrophilic salt, it will cause the dehydration of dispersion medium. Under these conditions, an addition of a small amount of electrolyte can cause coagulation.